Okay, I'm going to read the introduction. I just read chapter 1, Introduction to the SI. I'm going to read section 2, the International System of Units. Section 2.1, defining the value of a quantity. Defining the unit of a quantity. The value of a quantity is generally expressed as the product of a number and a unit. The unit is simply a particular example of the quantity concerned which is used as a reference, and the number is the ratio of the value of the quantity to the unit. For a particular quantity, different units may be used. For example, the value of the speed v of a particle may be expressed as v equals 25 meters per second, or v equals 90 kilometers per hour, or meter per second and kilometer per hour, or alternative units of the same value of the quantity speed. Before stating the result of the measurement, it is essential that the quantity being presented is adequately described. This may be simple, as in the case of the length of a particular steel rod, but it can become more complex when higher accuracy is required and where additional parameters such as temperature need to be specified. When a measurement result of a quantity is reported, the estimated value of the measurement quantity to be measured and the uncertainty associated with that value are necessary. Both are expressed in the same unit. For example, the speed of light in vacuum is the constant of nature denoted by c, whose value in SI units is given by the relation c equals 299,792,458 meters per second, where the numerical value is 299,792,458 and the unit is meters per second. Definition of the SI, section 2.2. As for any quantity, the value of a fundamental constant can be expressed as the product of a number and a unit. The definitions below specify the exact numerical value of each constant when its value is expressed in the corresponding SI unit. By fixing the exact numerical value, the unit becomes defined, since the product of the numerical value and the unit has to equal the value of the constant, which is postulated to be invariant. The 7 constants are chosen in such a way that any unit of the SI can be written either through a defining constant itself or through products or quotients of defining constants. The International System of Units, the SI, is the system of units in which the unperturbed ground state hyperfine transition frequency of the cesium 133 atom is 9,192,631,770 Hz. The speed of light in vacuum c is 299,792,458 meters. The Planck constant h is 6.62607,015 times 10 to the minus 34 joules seconds. The elementary charge E is 1.602176634 times 10 to the minus 19th coulombs. The Boltzmann constant K is 1.380649 times 10 to the minus 23rd joules per Kelvin. The Avogadro constant N sub A, I gotta pause this real quick. So the Avogadro constant Na is 6.02214,076 times 10 to the 23rd inverse moles. The luminous efficacy of monochromatic radiation of frequency 540 times 10 to the 12th Hertz. K sub CD is 683 lumens per watt, where the Hertz, Joule, Coulomb, Lumen, Watt with unit symbols Hertz, this HC, GC, LM, and W respectively are related to the units second, meter, kilogram, ampere, Kelvin, mole, and candela with unit symbols SM, kg, A, K, MOL, and CD respectively according to 1 Hertz is S to the minus 1, Joule equals kg, M squared, S to the negative 2, C equals AS, LM equals CD, M squared, M to the minus 2 equals CD, SR, and W equals kg, M squared, S to the negative 3rd, and then, or in words, Hertz equals inverse second, Joule equals kilogram, meters squared, inverse second squared, Coulomb equals ampere second, Lumen equals candela, meters squared, inverse meter squared equals candela, steradian, and W and watts equals kilogram, meters squared, inverse second cubed. The numerical values of the 7 defining constants have no uncertainty. Table 1. The 7 defining constants of the SI and the 7 corresponding units they define. Defining constant, hyperfine transition frequency of cesium. Numerical value, 9,192,631,770 unit Hertz. Speed of light in vacuum, symbol C. Now I should like to mention that this is the uppercase Greek letter delta. And this looks like a V, but it's actually a slightly different character. It's the Greek letter nu, NU. So you can just, I think that's helpful to know. So numerical value for speed of light in vacuum is 299,792,458 meters per second. Planck constant H 6.62607015 times 10 to the negative 24 joule second. Elementary charge E 1.6021766634 times 10 to the minus 19 coulombs. Boltzmann constant K 1.380649 times 10 to the minus 23rd joule inverse Kelvin. Avogadro constant N sub A 6.02214076 times 10 to the 23rd inverse mole. Luminicus efficacy K sub CD 683 lumen inverse watt. Preserving continuity as far as possible has always been an essential feature of any changes to the international system of units. The numerical values of the defining constants have been chosen to be consistent with the earlier definitions insofar as advances in science and technology allow. Insofar as advances in science and knowledge allow. Section 2.2.1 The nature of the 7 defining constants. The nature of the defining constants ranges from fundamental constants of nature to technical constants. The use of a constant to define a unit disconnects definition from realization. This offers the possibility that the completely different or new and superior practical realizations can be developed as technologies evolve without the need to change the definition. A technical constant such as K sub CD, the Luminicus efficacy of monochromatic radiation of frequency 540 times 10 to the 12th Hz, refers to a special application. In principle, it can be chosen freely, such as to include conventional, physiological, or other weighting factors. In contrast, the use of a fundamental constant in nature in general does not allow this choice because it is related to other constants through the equations of physics. The set of 7 defining constants has been chosen to provide a fundamental, stable, and universal reference that simultaneously allows for practical realizations with the smallest uncertainties. The technical conventions and specifications also take historical developments into account. Both the Planck constant H and the speed of light in vacuum C are properly described as fundamental. They determine quantum effects and spacetime properties, respectively, and affect all particles and fields equally on all scales and in all environments. The elementary charge E corresponds to a coupling strength of the electromagnetic force via the fine structure constant alpha equals E squared divided by 2C epsilon subscript 0 H, where epsilon sub 0 is the vacuum electric permittivity or the electric constant. Some theories predict a variation of alpha over time. The experimental limits of the maximum possible variation in the fine structure constant are so low, however, that any effect on foreseeable practical measurements can be excluded. The Boltzmann constant K is the proportionality constant between the quantity's temperature with the unit Kelvin and energy with unit joule, whereby the numerical value is obtained from historical specifications of the temperature scale. The temperature of a system scales with the thermal energy, but not necessarily with the internal energy of a system. In statistical physics, the Boltzmann constant connects the entropy S with the number omega of quantum mechanically accessible states, S equals K ln omega. The cesium frequency unperturbed ground state hyperfine transition frequency, the cesium-133 atom, has the character of an atomic parameter, which may be affected by the environment, such as electromagnetic fields. However, the underlying transition is well understood, stable, and a good choice is reference transition under practical considerations. A choice of an atomic parameter like the cesium frequency does not disconnect definition and realization in the same way that H, C, E, or K do, but specifies the reference. The Avogadro constant, Na, is the proportionality constant between the quantity amount of a substance with unit mole and the quantity for counting entities with unit 1 symbol 1. Thus it has the character of a constant of proportionality similar to the Boltzmann constant K. The Luminicus efficacy of monochromatic radiation of frequency 540 times 10 to the 12th Hz, K sub CD, is a technical constant that gives an exact numerical relationship between the purely physical characteristics of the radiant power stimulating the human eye and its photobiological response defined by the luminous flux due to the spectral responsivity of a standard observer LM at a frequency of 540 times 10 to the 12th Hz. Definitions of the SI units. Prior to the definitions adopted in 2018, the SI was defined through 7 base units from which the derived units were constructed as products of powers of the base units. Defining the SI by fixing the numerical values of 7 defining constants has the effect that this distinction is, in principle, not needed, since all units, base as well as derived units, may be constructed directly from the defining constants. Okay, I have to pause this.